Welcome to Introduction to Project Management, Managing Project Scope. This is Lecture B. The objectives for managing project scope are to analyze scope to develop the project scope statement, elicit stakeholder requirements for the project, create a work breakdown structure, WBS. We will focus on the first two objectives in Lecture B. As you are managing scope, remember the importance of explicitly processing requests for change of scope. It's not that scope can never be changed, only that you ought to make it an explicit process when there are requests to change the scope or change the requirements on the project. It is important to have a clear path for accepting requests for changes like this, and a process for evaluating those changes. Then the project team can determine the impact on project time, schedule, costs, and deliverables. These implications will guide the decision to accept or reject the proposed changes. If changes are made, your team will need to make all the necessary adjustments to document schedules, budgets, and deliverables, and communicate all these changes to stakeholders. A project steering team could be set up to handle all requests for changes. This would give stakeholders a way to remain aware of proposed scope changes and offer opinions on them. Consider this classic example of how a simple one-sentence change can have tremendous implications. Suppose a change request stated, any user could negate any change he or she had made during any interactive session. This simple one-sentence change might sound harmless, but there are tremendous implications for any system to accept the ability for users to undo any previous actions. This is often extremely difficult to implement. So-called simple changes may have enormous impacts on your system or your project, and the effort required to implement these changes must be considered seriously using your clearly defined process. Remember to see if your organization already has a process defined that you can adapt to your project. If there isn't, look into the resources mentioned earlier. See which parts of those processes are adaptable, and take the best points and create your own process. Now we will focus on requirements. We have said all along that requirements and scope are intimately related. As you define the scope, consider the requirements for the project and any resulting systems. There are many definitions of requirements in the literature and in practice, and requirements can come in all kinds of different forms. Requirements may include what the actual health IT system will do for the organization or for users, but may also relate to the response times by the system for user queries. Compliance with certain standards or laws or regulations can be requirements. Customers may require your project use some existing code or previous designs. There may be requirements for you to use particular development environments or test suites or particular commercial products. In essence, a requirement is any property of the project or system that determines its acceptability. Requirements can be classified as either functional, non-functional, or interface requirements. Functional requirements relate to what the system will do. Non-functional requirements involve how the users will use the system, and interface requirements talk about how the system relates to other systems and other organizations. In health IT projects and systems, another breakdown of requirements could be related to clinical versus non-clinical applications. For example, clinical application requirements may involve clinical decision support tools, such as alerts about lab values or X-ray results. Another example of these requirement types could include security and privacy of patient records, including access control and level of permissions and privileges. An attending physician will have more privileges in the system and will be able to do more things than an intern, resident, or a doctor in training. All of these factors need to be taken into account in your requirements. Also, consider the availability of your system. There may be a requirement for multiple redundant systems, disaster control, backup, system robustness, and exception handling for the software itself. All of these are requirements that you might elicit from your stakeholders, but also from your organization, which may have requirements that state the types of disaster control methods that must be put into place. How do you begin to determine the requirements of your project? Early indicators include the summary form that you found in the project charter, the development of the project scope, and the drafting of the project scope statement. It is tempting to think that you could try to nail down all the requirements at the start of the project, but this ambition is rarely realized and rarely realistic. In fact, it can often lead to a waste of time and effort. Due to the diversity in health IT projects, you really need to exercise judgment on how much of the requirements are knowable at the start of the project. You may know a great deal. It may be a project to implement electronic health records, EHR, in a large physician practice, and it may be similar to prior EHR implementations that you have done. In this case, the requirements are well known, and although the project is unique, it's really drawing on an experience base in which there is a lot of comfort and familiarity. At the other extreme, there may be little known about the requirements. There may be some new technologies that you want to explore in your project. For example, there are many possibilities in health IT settings for global positioning systems, GPS, applications. Using a GPS tracking system to locate a piece of expensive equipment is an example. In such cases, where the technology is unfamiliar, establishing exact requirements might be an entirely different situation. Requirements are a major driver in determining the best lifecycle process model to use for your health IT project. There are 4 broad classes of lifecycle models: linear models, iterative models, adaptive models, and the so-called agile models. They vary tremendously, especially the requirements and what is known about requirements in your project. In linear, also called sequential lifecycle models, you can proceed stage by stage or phase by phase. That may be fine for when requirements are known and understood and are highly stable at the beginning of the project. Some other projects may need one of the more flexible models, such as the iterative or adaptive models. You have a strong influence in your role as a project manager in identifying which project lifecycle model to use. In a large, multi-year healthcare IT project, you may use more than one of the life cycles. For example, you may use the linear project model for the overall project, knowing that you will start in this area and end in a different area. But then you may use the iterative or adaptive model for a small piece of the project, such as an infusion calculator, where you are not sure exactly how it is going to work and how it will affect the overall process. Next, we will examine some techniques for eliciting requirements that involve engaging the stakeholders and observing and analyzing work processes. Consider these techniques to be part of your toolbox for understanding requirements on your projects. To engage stakeholders, the first technique is to conduct focus groups or requirements workshops in facilitated sessions that bring the stakeholders together. That way, they can hear each other, and there can be discussion and, ideally, some accommodation and resolution if issues exist about certain requirements on the project. Consider retaining a skilled facilitator who is not on your project team. Facilitation is a particular skill and needs to be fully understood for its value in roles like this. What is likely to emerge from focus groups and facilitated sessions is a consistent set of requirements for which there's been discussion and general agreements among the stakeholders. If you have a facilitated session, also consider designating a person to be the recorder who will capture decisions and send that information as a document to confirm everyone's understanding of what transpired. A second way to engage stakeholders is to use surveys, which can be helpful in certain situations when you want to canvass people about their views on the system and the project. A third technique is to observe work processes. Examine the ways that people interact with existing systems and ask potential users what they like about potential interfaces. Can they talk about particular screen designs that are appealing to them and that they find effective in their work? Simply observing work processes and talking to customers, users, and stakeholders can clarify interface requirements. Always review your workflow diagrams with the stakeholders. Often, the stakeholders perform their work processes by rote without realizing the number of steps it takes to complete one process. As they review the workflow diagrams, they can point out where you have made mistakes in defining the process. In all these techniques, keep in mind the importance of good interviewing skills and good listening skills as you communicate with all these parties. These are skills that can be developed and honed over time and can be very useful as you determine requirements. Other methods to define requirements at the beginning of the project include developing prototypes and preparing scenarios. Prototypes can be very valuable. Consult references for prototyping. Prototypes are often good candidates to use for requirements that are difficult to specify using words alone. A prototype is not intended to be the real system. It is intended instead to illustrate some features and elicit feedback from users. Prototypes are widely used to show user interface screens. Essentially, what is behind the screen is stubbed out, so the user can focus on the clarity and usefulness of the interfaces themselves. The prototype can be an effective way of establishing interfaces that are useful and seem to be valuable for users. Later on, what's behind these interfaces can be developed as part of the project. Prototypes can be a valuable alternative to written language for things like user interfaces that are difficult to specify in text. Requirements in areas that are familiar, such as security and privacy, may also be cases in which you may be able to reuse requirements from prior projects. Again, even though projects are unique, there may be opportunities to pick up requirements in areas that tend to exist for all projects and reuse or adapt them as you write your requirements. Another way to elicit requirements is by using cases and scenarios. They can be very effective at showing relationships between users and the systems or services you're building in your project. Scenarios step through what the user does and what the system does in response, back and forth, showing the interplay between users and systems. They flesh out examples for the typical processes that will exist. There are tools to help you with prototyping and with building scenarios. With user scenarios, there's a large class of experience around a particular language called UML, Unified Modeling Language. There are tools to support development of UML, use cases, and user scenarios that will help you understand the relationship between the users and your systems. Something as simple as a PowerPoint presentation can assist you in demonstrating a product for your healthcare project. Build simulations of the screens in PowerPoint so the clinician can get a feel for how the screens will look and how they will progress. The clinician can say, at this point, we need X, or here would be a good point to put Y. In terms of requirements documentation, we will discuss 3 different documents. First, the requirements specification documents the requirements that you have elicited by engaging with stakeholders using prototypes and scenarios and conducting interviews. The second document is called a requirements management plan, which is your blueprint for managing requirements throughout the project. The third document is called the requirements traceability matrix, and it keeps track of the requirements and links them to the rest of the system and to the rest of the project. We will look at each of these documents in turn. The extent to which you will use these 3 documents will vary with your project, but we want them to be in your toolbox as a project manager so you can apply them as indicated. The first of the 3 requirements documents is called the requirements specification, which is an organized, structured document. It has sections, subsections, and so on to make it easy to serve as a reference and to make it easy to support changes as necessary. This is a document that captures what you've learned about functional, non-functional, and interface requirements, assumptions, constraints, and so on. Note that it really should include requirements for areas such as training and logistical support, and for operational support of any systems or services that you discuss in your project. In the requirements specification, look for opportunities to reuse requirements for areas that are in common, for example, security, privacy, and compliance. Sometimes performance requirements are a separate category of non-functional requirements. Performance requirements include elements like response times. It's important for you to structure requirements in a specific way that makes sense for your audience, that is, you, your project team, your customers, and stakeholders. You're providing visibility to all these important requirements because they determine the acceptability of your products and your project. Different groups will use these requirements specification documents in different ways. Clinicians will look at the functional requirements to be sure that they meet their needs on how the system will work, whereas technical requirements will be used by the IT staff to code the product to meet the functional requirements. Educators will look at your educational requirements to be sure that they have enough staff and enough time to build their educational scenarios to meet the requirements in the functional document. Expressing requirements is not easy. Our natural language has wonderful nuances and subtleties, but can also be filled with ambiguities. This can be marvelous in a novel, but if you're trying to be clear and concise about what a project or system is going to do, the beauty of natural language can make things open to interpretation, and that's not good in this context. For this reason, there have been efforts to give words certain specific meanings, such as something we call a reserved word. This is a word that is only used in a precise way, and the most common example is the word shall. For example, you would reserve the word shall for a case where you have what is called a must-have requirement. If you have a disciplined use of the word shall, it can allow organizations to count the number of occurrences of the word shall as an indicator of the magnitude of the level of requirements on a project. Requirements can certainly be made more precise by using reserved words like shall, but another way is to use structured languages, also called requirements specification languages. There are software tools that may be helpful to you that are categorized as computer-aided systems engineering or CASE tools. One of the most widely used languages is the Unified Modeling Language, or UML. There are many tools and models built around UML that may aid you in expressing requirements. You may be able to find IT staff who have relevant experience with UML tools and models because many of them are widely used across the industry. As you express your requirements, keep in mind the properties of well-written requirements, keeping them clear and concise. Requirements should also be testable. The acceptability of systems and services will be based on matching those systems and services and what they do against the requirements. The requirements should be traceable to the business needs that first appeared in the project charter, and the requirements should be usable by everyone, including the designers, who will be designing systems based on the requirements, and testers, who will be using the requirements to come up with test cases. Make sure your requirements have unique identifiers so it's easy to refer to them. It's also often reasonable to establish priorities for requirements to make clear which are the most important requirements. We talked about using the word shall to identify must-have requirements. In cases where there might be shortfalls in resources, you'll need to know which are the most important requirements to make sure they're implemented. Make use of the experts you have on hand. If you are not from a clinical background, find a clinician who can help you translate the requirements into clinical language so that your clinicians can understand them easily. If you are not from an IT background, find someone on the IT side to help your coders and IT staff to understand the requirements and what you are requesting. Here is an activity to highlight some of the issues and challenges in using English to express requirements. Consider these statements on the slide as if they were written to be requirements, and consider the extent to which they have the desirable properties that we have discussed. Studying them will expose some of the issues of writing requirements effectively. This concludes Lecture B of Managing Project Scope. In summary, we have taken a deeper dive into defining scope and requirements and into setting up the first of 3 documents, the Requirements Specification document. We have discussed the importance in your role as the project manager of taking changes in scope and requirements very seriously, as a simple statement can change the scope of your project substantially. We also discussed options for communicating clearly the requirements to your various stakeholders.